So today we're going to talk about tectonic plate boundaries. So we're still looking at lesson 1, Earth's moving surface, and we'll go back to some concepts that we've talked about before, some yesterday, some in chapter 3, but let's look at the way that these plates kind of, as the not really how much so much how they move, but what happens where they meet and kind of how are they moving. So there's 3 different types of boundaries we're going to look at today, and so this is kind of an overview of the different types. And so as different plates where they meet, you've got different types of boundaries, because if they're moving, then you're going to have them moving in different ways in respect to the other plates. So the first type of boundary I want us to look at is a divergent boundary. And this is the boundary between 2 plates that move away from each other. So imagine then here that you've got your 2 different plates, and you have magma coming up from the mantle and kind of pushing the plates apart. Now, with all of the surface of the Earth, these plates are tight together, so they wouldn't just magically drift apart. Something would have to be pushing it. And so this is where we go back to the concept of uplift that we talked about in the rock cycle. So you have either uplift of rock or magma, either way, but it's pushing the 2 plates apart. Now there's different formations that come from these divergent boundaries, and you have first what's known as a rift valley. So you have magma coming up and kind of pushing the plates apart, and it forming this valley here, kind of the rift there. So it's volcanic, but you just kind of see it's not so much the typical cone-shaped volcano. It's more of this valley that is volcanic at the bottom. But then as that spreads further and further apart, you get what's called a new ocean basin. So you start out here with the Rift Valley, but then as it spreads further and you get new crust formed here, these continental crust plates will push further apart, and then you have this kind of smaller sea or ocean forming. But then you get the mature ocean, and this is where you have the full-on oceanic crust at the top of the lithosphere, and then you get what's called a mid-ocean ridge. So one of the ways that we know this is one of the pieces of evidence we have for this, and this is called seafloor spreading, by the way, is that when they examine the age of the crust around the ridge, the mid-ocean ridge that's formed, the rocks nearest the ridge, or the crust nearest the ridge, is the youngest. But then if you examine the rocks as they move out on either side, they correspond to each other, they get older. So that means that these parts of the continental crust, and this is specifically in South America and Africa, and we're looking at the mid-Atlantic ridge, these are of similar age. So what happened is these were together at one point, and then this rift formed and eventually spread out to where we have an ocean. And now what we have is this mid-Atlantic ridge. And so that's a divergent boundary. That's where they're moving apart. The second is called a convergent boundary. And this is the boundary between 2 plates that move toward each other. So here you have one example here is you have an oceanic crust, and as they move toward each other, one is going underneath the other one. And we've mentioned this process before. It's called subduction. Again, when we talked about the rock cycle, we talked a little bit about subduction. But subduction is the process that occurs when one tectonic plate moves under another tectonic plate. So you see that here, you've got one moving down under the other one. And so here's an example of of a subduction zone, and this is specifically in the American Northwest, so around Washington and Oregon. And you have a smaller plate, the Juan de Fuca plate, coming up against the Pacific plate, and then here the North American plate. And this is causing earthquakes in different places. You have the locked zone, you have what's called slab earthquakes, crustal earthquakes, volcanic earthquakes. But volcanoes are another important part of subduction zones. So you see that as it comes under the other plate, it pushes up, creating these volcanic ridges here. And then there are a few different types of convergent plates, subduction zones. You have here oceanic crust coming underneath continental crust. You have oceanic crust coming underneath more continental crust, or more oceanic crust. And here, the volcanoes that formed actually become volcanic islands. And if you look specifically like in the Pacific Ocean, you see a lot of examples of this. And then you have continental crust coming under continental crust, and this would create mountain ranges and high plateaus. And you can see that at some point there would have been oceanic crust. Now here's a map of some of the major subduction zones on Earth here. If you follow these, you have along South America here, and the Nazca Plate, the Cocos Plate, and the Caribbean plates you can see. And here it was the one we looked at earlier, the Juan de Fuca Plate along the North American Plate and the Pacific Plate. But you see all of these are areas where you're going to see the plates sliding underneath the other plates. And then the last type of boundary is called a transform boundary. And so this is the boundary between two plates that slide past one another. So rather than coming apart or being pushed together, these are sliding back and forth against each other. And here you have, again, this would cause earthquakes, as what's known as the zone of shearing as they rub together. There's rocks that's displaced, and you see, again, the plates are moving along the asthenosphere here. But that's a major cause of earthquakes. And one place that's very popular is the San Andreas Fault outside of Los Angeles in California. And this is known to cause a lot of earthquakes in this area. And that fault there is a transform boundary. So what's happening is the Pacific Plate is moving kind of northwest, and the North American Plate along that fault is kind of sliding down to the southeast, and that is causing these earthquakes. But another place that you see them is actually alongside of the ocean floor spreading, or the divergent boundaries. They do not always occur in a straight line. So what will happen is you have these fractures between divergent boundaries on the ocean floor, and these will create transform boundaries. And so here is another example of that as well. And so here you have your divergent boundaries. You have your younger rock closer to the divergent boundary, and then getting older as it spreads out. But then they are shifted. You can see here you have the rift kind of coming apart along a transform boundary. So then you have younger rock or younger crust alongside older here, and the reason for that is this shift along the transform boundary. So all three of these work in conjunction to move the plates around and cause different landforms, and they're one of the biggest causes of volcanoes you see here again, and earthquakes along all of the different types of boundaries.